Hello everyone. Until now, we've been talking about the visible spectrum, just the colors from violet to red. But here's the catch, that's only a tiny slice of the full spectrum of light. Experiments with sunlight show that beyond the red and violet edges lie invisible radiations that our eyes cannot detect. This hidden extension is called the invisible spectrum. So while our eyes stop at violet and red, nature continues the spectrum far beyond. Now let's classify the electromagnetic spectrum. If we arrange by increasing wavelength or equivalently decreasing frequency, the order is gamma rays, X-rays, ultraviolet, visible light, infrared, microwaves, and finally radio waves. Gamma rays have the tiniest wavelength and the highest frequency, while radio waves have the longest wavelength and the lowest frequency. But here's the beauty, whether it's gamma rays or radio waves, all of them travel at the same speed in vacuum, 3 times 10 to the power 8 meters per second. Time to bring in some math. The link between these quantities is given by a simple but powerful relation, c equals f multiplied by lambda. Here, c is the speed of light in vacuum, which is 3 times 10 to the power of 8 meters per second. F is the frequency measured in hertz and lambda is the wavelength measured in meters. Since c is constant, if the frequency goes up, the wavelength must come down. And if the wavelength goes up, the frequency must come down. Let's begin with the long wavelength side, beyond red. First comes infrared radiation. Its wavelength is slightly longer than red light and it's used in TV remotes, heaters, and night vision cameras. Next are microwaves. With even longer wavelengths, they are the heroes of radar, satellite communication, and of course, microwave ovens in your kitchen. And at the extreme end are radio waves, the giants of the spectrum. Their enormous wavelengths make them ideal for broadcasting radio, television, and wireless communication across the globe. Now let's move to the short wavelength side, beyond violet. First up, ultraviolet rays. They help your body produce vitamin D but can also cause sunburns. Next are X-rays with even shorter wavelengths and higher energy. They are widely used in medical imaging, airport scanners, and materials testing. And finally, gamma rays, the champions of high energy. They are produced in nuclear reactions and are powerful enough to treat cancer, but also dangerous without shielding. Notice the rule, as wavelength shortens, energy and penetrating power increase dramatically. Let's do a quick calculation. Suppose a wave has frequency f equal to 6 times 10 to the power 14 Hz that lies in the visible range. Using the relation c equals f multiplied by lambda, we substitute 3 times 10 to the power 8 equals 6 times 10 to the power 14 multiplied by lambda. Rearranging, lambda equals 3 times 10 to the power 8 divided by 6 times 10 to the power 14. That gives lambda equal to 5 times 10 to the power minus 7 meters, or in simpler terms, 500 nanometers. That's exactly in the green region of the visible spectrum. Isn't it amazing how just one formula can pinpoint the color of light? Let's summarize. The electromagnetic spectrum stretches from gamma rays at one end to radio waves at the other, with visible light just a tiny band in between. The order by wavelength is gamma rays, X-rays, ultraviolet, visible, infrared, microwaves, and radio waves. All travel at the same speed c equal to 3 times 10 to the power 8 meters per second in vacuum. The key relation c equals f times lambda links wavelength and frequency. These waves power almost every aspect of life, from cooking your food to scanning bones to studying distant galaxies. The M spectrum is not just physics, it's the invisible backbone of modern science and technology. See you in the next session.